This lesson will prepare you for section 7.4, and in doing so it's going to introduce you to a whole new type of number. So we're going to start by considering this quadratic equation, x squared equals 1. So in order to solve this equation, you've learned a few different methods, but the fastest one here would be to take the square root of both sides, remembering that the square root of x squared is x. And when you take the square root of both sides, you need to remember to introduce the plus or minus symbol, because numbers actually have two square roots. And then if you think about the square root of 1, that's 1. So the two solutions to this quadratic equation are plus or minus 1, which makes sense because if you plug in a 1 and square it, you get 1. Similarly, if you plug in a negative 1 and square it, you also get 1. So now we're going to look at a quadratic equation that looks quite similar, but actually in order to solve it, we'll need to learn a new type of number. Okay, so now we're going to look at x squared equals negative 1. So I'm going to start the same way. I'm going to take the square root of x squared, that's x. I'm going to introduce a plus or minus, and I'm going to take the square root of this side. And then x equals, well, here's where we run into a problem. If you're trying to find the square root of negative 1, you're going to have a hard time finding it because the answer can't be positive because a positive number will square to give you a positive number. The answer cannot be negative because if you square a negative number, you get a positive result. So I'll recopy my plus or minus and introduce this new number called I, which stands for imaginary. This is a whole new type of number. It's just being made up so that we can solve the equation x squared equals negative 1. What is I? I is the square root of negative 1. Now, sometimes our equation is more complicated and might require the quadratic formula. So in this example, a is 1, b is 4, and c is 5. So I'm going to plug into the quadratic formula. X is negative b. Here that's negative 4, plus or minus the square root of b squared, 4 squared is 16, minus 4 times a times c, or 4 times 1 times 5, 20. And then it's all over 2a, so all over 2, because a is 1. Alright, so I get negative 4 plus or minus the square root of negative 4 all over 2. Or x equals negative 4 plus or minus. And now we need the square root of negative 4. Well, I'll explain this in more detail on a future screen, but for now, square root of 4 is 2, so the square root of negative 4 is 2i. And the denominator is 2, and then we could simplify that by splitting both terms in the numerator in half, negative 2 plus or minus I. So I solved that one partially so you can see that complex numbers can have a real part and an imaginary part. In this case we have 2 plus I and 2 minus I. Okay, that was very fast, but that introduced you to this new type of number. Now let's look a little bit more at what that really means. So first of all, I is the square root of negative 1. That's what it is. And if you needed, say, the square root of negative 25, well, negative 25 is negative 1 times 25. And you can take the square root of each of these things separately. The square root of 25 is 5, and the square root of negative 1 is I. So in general, if you know the square root of a positive number like 36, in order to find the square root of its opposite, well, the square root of 36 is 6, so the square root of negative 36 is 6i. Suppose it were a number like negative 30. Well, I don't really know what the square root of 30 is, but I do know that it has some square root. And if I multiply that square root by I, I'll get the square root of negative 30. So that's just sort of the basics of what I means and how it can be used to find square roots other than the square root of -1. Okay, the next big thing to learn is how you operate with complex numbers. So operating meaning addition, subtraction, multiplication, division. So when you are adding or subtracting complex or imaginary numbers, just think about combining like terms. For example, if you had 3i plus 4i, well, if you had 3x plus 4x, it would be 7x. You do the same thing. 3i plus 4i is 7i. Now, you might have something more involved, like you might have a number with a real and an imaginary part, 2 plus 6i, and maybe to that you're adding 7 minus 9i. Well, again, it's just a matter of combining like terms. The like terms here are 2 plus 7, that's 9, and then 6 plus -9i would be minus 3i. And we can do something similar with subtraction. If we have the number 2 plus 6i, and we're asked to subtract 7 minus 9i, well, we are just going to look for like terms. 2 minus 7 is -5, and 6i minus -9i is 6i plus 9i, and 6 plus 9 is 15, so I get -5 plus 15i. And that's basically how you add or subtract when you have complex numbers. Now, multiplying, you're going to use basically the definition of I, as well as the distributive property, and in some cases, FOIL. So for example, if you had to multiply, say, let me put the pen back on. If you had to multiply 3i by 5i, well, again, think 3x times 5x is 15x squared. Well, this will be 15i squared. And then by definition, I mean I squared is -1. So 15i squared is 15 times -1, or -15. Here's where the distributive property comes into play. Suppose you had 3i and you were multiplying it by 2 plus I. You'd distribute the 3i and you'd get 6i plus 3i squared. And then the 6i, I just rewrite. Since I squared is -1, that becomes -3. And then typically we like to write the number with the real part first, -3, and then the imaginary part at the end. Okay, FOIL is going to be useful when you have something like this. 3i plus 2 times 2i minus 5. All right, so 3i times 2i is 6i squared. And then let's consider our inner and outer products. This is 4i, and this is minus 15i. So 4 minus 15, so I get minus 11i, and then 2 times -5 is -10. Now keep in mind, I squared is -1, so 6i squared is -6, minus 11i, minus 10, and then we're going to combine the real parts. -6 minus 10 is -16, and then minus 11i. Okay, so that's a quick look at how to add, subtract, and multiply with complex numbers. Complex meaning there could be a real as well as imaginary part to the number. We will look at division together in class, because I need to make sure that you've got the adding, subtracting, and multiplying under your belts first. Okay, for your homework. Number 1, solve the equation 3x squared equals -75. Try to do that by isolating x squared and then taking the square root of both sides. And then here on number 2, I actually want you to do, this is 6 separate problems, A, B, and C. Ask you to add, multiply, and subtract 3i and 7i, and then D, E, and F. I'm giving you complex numbers with a real and imaginary part and asking you to add, subtract, and multiply. Okay, have that ready for class next time.